Okay, so welcome to the end of the trig unit, which is looking at triangles that are not right angles. So now we're going to expand how many triangles you can deal with, how many sides and angle measurements you can find. So the first law we're going to learn is sine law, and then on Wednesday will be cosine law, and then Friday will be word problems for sine law and cosine law, and also choosing whether you're going to do SOHCAHTOA, sine law, or cosine law. Okay, so if you want, at the top of your page, I recommend you write not for right angle triangles, to draw attention to that, because you definitely don't want to use this when you have a right angle. When you have a right angle, it's easier to use SOHCAHTOA. So one of the things we do with triangles is label them. And the way, you're used to labeling, say, across from the 90 degrees of the longest side is the hypotenuse. We're going to use capital letters and lowercase letters. So capital letters, I'm just going to do ABC. You could really pick whatever you wanted. Capital letters, we're going to reserve for the vertices or the angles. Okay, and then what we do for the side lengths, you go across. So the opposite side of A is down here, and we use lowercase letters. So this is side A. Across from B, little b, across from C, little c. Okay? All right, so when this triangle here has a height drawn into it in purple, and so what we're going to do is you can use that to prove the sine law. So in 8.5, when we did problems with two triangles, you would have looked at this as two little triangles. But that meant you had to know something about one of the sides, two of the sides. So that's not always the case. And then you, like, say you were looking for length BC, then you would do the one triangle on the left and add it to the one triangle on the right side, and that would give you the total length. We can now use the sine law in order to find BC without having to do that. Okay, so the reason, or this, we're going to do a different law, like I said, the cosine law, but this one is going to be specifically about using the sine ratio. Okay, so here we have the sine law. So in any acute triangle, the ratio of each side to the sine of its opposite angle are equal. So we'll use two different variations, but it really doesn't matter if you use this form. So if you want to get out your highlighter, this is when we're looking for sides, and this is when we're looking for angles. You can actually use either one, but when we do those questions where sometimes the X or the unknown was in the bottom, if you didn't like that, then maybe you want to flip it around. So you can see it's either side A over sine A, side B over sine of angle B, and side C over sine of angle C, or the sine is in the top, sine of angle A over side A, sine of angle B over side B, sine of angle C over side C. So you can't mix them around. Like, you can't do things like this. Okay, you can't do that. They have to either all be sides in the top, all lowercase letters like A, B, C, or they have to be the angle form, sine A, sine B, sine C. And if this was a real, if we were going to write a real test, then you would be given, you're given the formula for this and on the exam as well. So we just need to practice with how to use it. So here there are 3 sides and 3 angles. That's a triangle. That's always the way it is. What we're going to do is, what you really need is a ratio like we've been solving before. So we'll write the sine law out and then we'll plug everything in, but then we're going to kind of have to split it up. So we're going to do the same thing like we did with similar triangles, and it was a complicated problem because you need to have one complete ratio. So you need to have one side and its corresponding angle. Okay, so then when we do cosine law on Wednesday, that will be what you're looking for. That'll be the difference. You won't have, say, like this complete ratio or this one or this one. You'll be missing something. So then we need another law, the cosine law, to deal with that. Okay, so maybe it's easiest to see if we do a problem. So given triangle ABC, find the lengths of the sides A and B to 1 decimal place. Okay, so I'm going to write out steps. If you're a step kind of person, we need to label the sides. Okay, so remember across. So B, little b is over here, across from B. Little a over here across from A, and little c over here across from C. Okay, so since we want to do, we're finding sides, then I'm going to use that form of the sine law, but it really doesn't matter. Okay. And then fill in what we know. So we do not know the side, we do not know A. We do know that angle A is 45. So sometimes what people like to do is they like to actually make bubbles, okay? So this goes together, this goes together, and this goes together. Okay, so if you find that's distracting or too cluttered, then don't do it. But if you do like that, then I recommend that you do it. You could even do, if you have it, do 3 colors. Okay? Maybe that'll stand out even more. So it really, I had kids who did this last semester. I had kids who didn't. It really kind of depends what you like. Okay? So now angle A is 45. It goes with side A across from it, but we don't know that. We don't know what A is. And I mean, it's in the question what we're asked for, right? Same thing with B. We don't know side B, but we know angle B is 65. And then we have something is missing in your picture here. Sorry about that, guys. Side C is 9 because we can't have all unknowns. So side C is 9. I'm just going to write 9. I'm not going to include the meters for now. I'll remember to put them in at the end. So that's a 9, not an A, over 70. Okay, so now we have one complete ratio. So we have this one here. Let me see if I can get... So we have this complete ratio here, and then we have two incomplete ones. So now we have to split up, okay? So I'm going to do A sine 45 and 9 over sine 70 and B over sine 65 and 9 over sine 70. Okay, now let me... Oops. Okay, so it doesn't really matter which side you do first. And again, if you found that last section you preferred to type in sine 45 and sine 70 and see what they were as numbers, you can do that, or you can keep them together. So I'll do both. I'll do the A where I type in the numbers and make sine 45 a number and sine 70 a number, and then I'll solve for side C and leave them and do all the math like in the calculator at the end. And it does not matter which way you do it, okay? So sine 45 is 0.7071. Oops. And sine 70 is 0.9397. Okay, so now this looks a little bit less scary. Now you continue on. And I'm going to do 9 divided by 0.9397. Okay, and now A is like my X, so I need to get it on its own. So I'm going to do the opposite operation so that this cancels out. And it says 1 decimal place, so I'm going to do 1 decimal place. Okay. And then, so now let's do this one over here. So like I said, I'm going to leave the letters in. And this one, I'm actually going to do, thinking of it like cross multiplying, okay? So I'm going to even do it a little bit different. So we're going to do B times sine 70 and 9 times sine 65. And it does not matter what you prefer, okay? Now, but this time, why am I doing 65? Because now I'm doing side B, okay? And across from B is 65. So I'm doing the second ratio. I've already solved for side A. If it helps you, write that in. You can do that. So then you can see that all you're left with is solving for side B. You can do that. You could have also now used the A over sine 45 because now we know what A is. But most people stick with what they're given, but it doesn't really matter. Okay, so we have B times sine 70 equals 9 times sine 65. Sorry for the squishing. Okay, now I want, actually I'll do this first. Okay, now I need to get B by itself, so I'm going to divide both sides by sine 70 so that it cancels out. and I get 8.7. Okay, so now I've solved for side A and I've solved for side B. All done. Okay, let's do one with angles. So this time we're looking for angle A and angle C. First I need to, number one, label the triangle. So I'm going to follow the same steps, but I'm not going to write them out again. I don't think you need to do that. Okay, so we have, actually I'll just write one label. Okay, so we have side C across, we have side B, and we have side A. I'll do highlights. Okay, so all right. Then, so our triangle is labeled. Then we are going to, now we are looking for angles. So I'm going to use the form of the sine law with angles on top. Not that it really matters. The other one would work as well, but the unknown would be in the bottom. So if that bothered you in the last sections with SOHCAHTOA, then flip it around, easy peasy, okay? Just make sure you flip them all, that's all. All right, so now fill in what we know. So sine, we don't know A, that's what we're asked for. We do know its side. Since angles have just degrees as their unit, you don't need the centimeters here. Sine B is 36. And sine C over C. We don't have any of that. So we're going to then, so now this question's a little bit more obvious because we don't have side C and we don't have angle C. So we can't use that at all. So you want to lightly put a little X through that. What we're going to have to do is solve for angle A, and then we can plug in, or we can use the property of triangles that all the interior angles add to 180 to find angle C. We could also redo the sine law, which is absolutely fine, but a lot more work. Okay, so if you want to do that, you can, but you don't need to. So use ratios with only one unknown or variable. So same thing like we did up there. We're not going to do C because we don't know any of those. So now we have sine A over 23 and sine 30, oops, sine, not sim, sine 36 over 16. Okay, so it's up to you, again, what you want to do here. Maybe it's even easier just to do sine 36, push equals in your calculator, and then do divide 16. Okay, what I'm going to do is I'm gonna go this way. Sorry. Okay, so what I did sine 36, push equals, and then divide by 16. I just solved the right-hand side of the ratio. And now to get rid of the 23 in the bottom, you multiply. Okay, and now we're at a step like we did with SOHCAHTOA, where you have to get rid of or solve for the angle A, so that would be inverse. So sine inverse here. and you get 57.7 degrees. So you can put that right in your triangle if you want, 57.7. Okay, and then all we have to do now is solve for angle C. So like I said, I'm going to write it up here because I'm out of room. Sorry about that. Okay, so angle C, you can do 180 minus 36 minus 57.7, and you get 86.3. You can certainly do ratios again and use the sine law, but you can also make your life a little bit easier. Okay, so there's the homework. There are no word problems yet. We're going to do those on Friday. So please try to practice with this. Really, one of the hardest things about this is using your